Hey guys, nice texture we got here. But you know what would be better than this? Two textures. Yeah, baby. Okay, so we're gonna do two textures. Let's hit up Google. Nice texture again. Let's see what we get. Actually, I saw that's perfect. Yes. You're going in my game. So we'll call it texture 2. There we go. Okay, so first of all, let's make sure it loads. So I'll just change the texture here to texture 2. Alright, works fine. It's a little bit wider, but that's okay. And why is he wider? Why doesn't it keep the aspect ratio? The UV coordinate system does not care at all about the size of the image. It doesn't take into account what if the image is some sort of weird aspect ratio. It assumes that the picture is a square. It will just sample all the pixels from the top left to the bottom right corner, regardless. And also drawing it out, we're just drawing a square. Well, it's a rectangle, but and again, we don't take any sort of aspect ratio of the actual square into account. We just take the texture coordinate square as we were giving it. As we were given it from 0 to 1, we're taking all pixels into account, no matter what the aspect ratio is. So OpenGL, for the most part, does not know or care about resolutions or aspect ratios. Once it is a texture, all it cares about is the UV. Cool. So let's make another texture. So instead of damn things on the floor. Okay. Yeah. So let's load another texture. Let's actually make a function for this. GLUint load texture. So we'll give it a path. And let's just pop this bad boy in there. So I'm just gonna take this whole bunch of code and put it in that function. Oops. Like so. And then instead of hard coding this texture.jpg, I'm just gonna do path instead. Like so. And then I'll return the handle. So return texture there. Alright, so now we have a nice function to actually load the textures for us, so we don't have to use copy the code twice to load two textures. Two textures. Hooray. So we'll do GLUint texture 0, and I will do load texture, and that's gonna just be texture.jpg. And then we'll do texture 1, and that's texture 2. That's what became very confusing, but it's fine. We know what we're doing. Okay, cool. So why did this guy show up? Like, did it matter? Like, how did it choose? Well, just like with everything else in OpenGL, the texture that gets drawn, or rather gets sampled with the texture function in the shader, is the currently bound texture. Remember when we were binding textures in here, this GL bind texture to a certain slot. That is the texture that gets sampled in the shader for its particular slot, I should say. So the sampler 2D will sample the GL texture 2D slot, and the 1D texture will sample the one directional texture slot and the cube map slot and so on. So we can have one texture bound for each slot, and then the sampler will just read its corresponding slot. But still, only one can be bound at a time. So we can change which texture we want to show with the GL bind texture function. So we'll do GL texture 2D, and I'll do texture 0 then, because that's the one that wasn't bound. And now we should get, there we go, we get the, whatever that is, the cool background. Also, you know what? Just a little like quality of life thing. Whoops! No! Get away. Do you see this? Do you see, like, as I resize the window, the like the G, whoops, the quad doesn't change, which is kind of weird. Like, it would be better perhaps if, you know, as we resize the window, the actual GL drawing space also changes, because what's happening here is that OpenGL actually only draws to the same square here. This cannot be drawn upon. It's not like, you know, the NDC square gets changed or resized. It's still this square. It's still the square here, and this is just black. It's just nothing. It just gets set to the clear color. And OpenGL keeps track of this internally with a function called GL viewport. So let's check it out. GL viewport. So here, it takes 4 parameters: GL viewport X, Y, width, and height. And what this does is set the pixels on the window that it's considering to be, you know, the output square, the output viewport, where it should output pixel, where it should map the NDC square to pixels in the window. And XY specifies the lower left corner. So in our case, that's 0, because it's drawing it down here. You know, it's starting down here. And then you specify the width and the height. Right. So when you open a GL context, and you can see that here, when a GL context is first attached to a window, width and height are set to the dimensions of that window. So what does that mean? It means when the context is created, i.e. we open a window, the GL viewport gets set to just the dimensions of that window. Pretty simple. But when we change the size of the window, that GL viewport is not updated. All right, we have to update that ourselves. So let's do that, because I've been actually it's been bugging me a little bit when I want to zoom in the texture. GLFW has a nice callback for this. So let's do GLFW documentation just to check that out. I'm gonna get I think window guide. I think window size, no, frame buffer size. Yes, this is what I want. Yeah, you can see here it sort of explains why you want frame buffer size. While the size of a window is measured in screen coordinates, OpenGL works in pixels. The size you pass into GL viewport, for example, should be in pixels. On some machines, screen coordinates and pixels are the same, but you can fucking read. I don't know why I'm reading. So this is a special callback that makes sure that, you know, the size we're getting is the actual size that OpenGL is expecting, and not some sort of screen coordinate specific thing. And I'm guessing this has to do with stuff like the DPI scaling on your screen and so on. I actually don't know. I'm not fully aware of what exactly is going wrong, but I trust in the GLFW documentation. So we're going to use this GLFW. I forgot. Set frame buffer size callback. There we go. Set frame buffer size callback. So this is going to be window, and we'll call it void handle frame buffer resize. All right. And let's see here. It actually specifies what the callback is. It takes GLFW window pointer as the first argument, and then width and height. So that's pretty cool. So we'll do GLFW window, and then width and height. So this is going to get called every time I resize the screen. So in here then, we will just call GL viewport. So we'll update the OpenGL's viewport to be the new size of the actual screen. X and Y, we don't care about. We don't want to position the viewport anywhere. We want it to cover the whole screen. So for X and Y, I'm just going to type 0. And then width and height is just going to be the width and height of the frame buffer. And that's just going to be it. So let's handle frame buffer resize. No, I don't want to call it. I just want to pass it in. And now hopefully, with a little bit of luck, if I resize the window, Yeah, there we go. So now it's resizing the OpenGL context to actually, or the OpenGL viewport to actually fit the new screen. So now I can make the square, any aspect ratio I want. So that's cool, and it'll, a nice little quality of life thing. That's been bugging me a little bit. Okay, so now, so we're binding a texture. Right now we're binding texture 0. If we want to flip back and forth between 0 and 1, texture 0 and 1, we could take the time, for example. So time is in seconds, I think, yeah. So I'll just get the time seconds. I'll just cast it to an int. And I'll just check if time seconds mod 4 is more than 2, then GL bind texture. This doesn't really matter. I just want to do something texture 0. Otherwise, I'll bind texture 1. Let's see what happens. All right, cool. Oh, it should be more than equal to. So now, with this clever little bit of mathematics, we should be swapping the texture every 2 seconds. So now you can see if I'm binding one texture, that gets rendered, and if I'm binding the other texture, it gets rendered. So this little mathematical fuckery that I did, it doesn't really matter. What I'm trying to tell you or show you is that, binding the texture is how we affect what happens in the shader when it's sampling. So the sample always happens on the bound texture. Nice. But what happens if I want to fade from one to the other? Okay, so I want to fade from one to the other. Well, that doesn't really work right now. Like, here I'm swapping that, but I can't get like the in-between. I can't fade them in an easy way. I might be able to, maybe draw one quad on top of it with like an alpha or something. But it seems like a bit of a nuclear option to solve what should be a pretty easy solution. So how do we bind two textures at the same time? Because if I could do that, I can mix the color in the shader. I can mix from one of the textures to the other and mix that in the fragment shader. So how does do such a thing? Well, you saw that this usampler here, that's a uniform. All right, it's a uniform of type sampler 2D. Well, a uniform is a parameter, so we can set the parameter. But what do we set it to? Do we set it to the texture, like the texture handle, or what do we do? Well, I'll tell you that I've been lying a little bit when I was saying there's only one slot for a texture. There's actually many slots for textures. Believe that. With the function called GL active texture, check that out. GL active texture specifies which texture unit to make active. The number of texture units is implementation dependent, but must be at least 80. All right, so what this means is that there's actually up to 80 different slots where you can bind textures in. All right, so it works kind of like this. If I make some square, that's a circle. I make some squares here. Nope. And so on, you get the picture. ... So if we say these are individual GL texture slots, all right, so we call it slot 0 and slot 1 and 2 and 3 and 4. So by default, slot 0 is the one that's actually active right now. So when I call GL bind texture with a handle, let's say it's handle 1, or handle 2, and I call GL bind texture with that handle, it gets bound into the currently active slot. All right, and that's 0 by default. So right now we've been just binding textures to slot 0. So this becomes 1, and then after 2 seconds we're binding GL texture 2, so slot 0 becomes 2, and then after 2 seconds we bind it to 1 again. All right. So we're always binding to slot 0 when we call GL bind texture. But if we somehow changed which slot was active with GL active texture, so let's do that. So if I do GL active texture, and then I'll call GL texture 1, like so, this will change which slot is currently active. So instead of slot 0, now slot 1 is going to be active. And what happens then is every subsequent bind texture call is going to bind the handle to slot 1, which means that 1 will be bound to slot 1, and then after 2 seconds 2 will be bound to slot 1, and after 2 seconds again 1 will be bound to slot 1, but slot 0 will keep its bound state. So this 1 here will keep being bound on slot 0. So what does this mean for our shader? Well, if we do this, if we actually run this program now with me doing the GL active texture call, what happens? Okay, so it's rendering this one as texture 0 here, which is the texture I bound before calling GL active texture. But that is staying on there. Even though I'm calling GL bind texture here with a bunch of different textures, this is not changing because I changed which slot I was binding into. So I'm binding the slot 1. Slot 1 is going crazy, but our uniform, our sampler, is only sampling from slot 0. Okay? And that's where the uniform comes in. The value of the sampler, which is like, uniform is which is a parameter that we can set, specifies which slot this sampler is sampling from. It doesn't specify which texture, like which texture handle. It specifies which slot to look at to get the handle from. All right. So currently our uniform, maybe the risk of being a little bit too obvious or too explanatory, we'll do U sampler. That's equal to 0. All right. So that's the default value for samplers. And that means when it calls texture, or when we call texture rather, to sample a pixel, it looks, okay, my name value is 0, which means I should look in slot 0 to find which texture to sample from. Okay, on slot 0, texture 1 is bound, which means that, okay, I should look at texture 1 to find which pixel goes where. And when I'm saying texture 1, I'm saying, when we got the handle, it happened to be a 1. It could be a billion. It doesn't really matter. I'm just using 1 and 2 as examples, but you can think of them really as A and B. I think that would probably be better. Texture A and texture B. Let's actually do it. Let's just remove this. There we go. So it looks in slot 0 and says, oh, texture A is bound to slot 0, so it looks at texture A. Okay, so it does this sort of double lookup. But if we could change which slot index to look at, so if we set our sampler to, instead of look at at slot 0, you're gonna look at slot 1. All right. Then when we call texture, if only there was like an eraser tool or something. Oh, well, we can only dream. It will look, okay, I'm bound to slot 1, so it will look at slot 1 and see that, oh, okay, okay, now nothing is bound, but in tick we're binding stuff all the time. Oh, it's bound to texture B. So it will look up the pixel from texture B. So that's what the sampler does, and that's how we can modify the sampler to look at different active texture slots, which means we can have 2 samplers in our shader bound to different texture slots, which allows us to bind multiple textures and render them, in one shader, or sample them in one shader rather. So let's do this. theoretically out of the way. First of all, we gotta get the uniform. You know, you remember when we get the U color and the U time. We call this GL get uniform location, and it's the same thing for samplers. We just call this GL get uniform location. So we'll do GL int U sampler, because that's the name of the uniform in the shader. Excuse me. We'll do GL get uniform location U sampler. And let's just, you know, set it to look at slot 1 instead of slot 0. So we'll call GL uniform. And it's not a float, because, you know, looking at slot 0.5 wouldn't really make any sense. It's an integer. All right, so it's an integer uniform. And it's only one. It's not a vector. It's only one int. So we call 1i. So 1i for integer. So we call GL uniform 1i. And then location is U sampler. And then here's the value. So the value is going to be which texture slot to sample from, and we'll call it, and we'll do 1. All right, so what's going to happen now? Can you make a guess what's going to happen now? It's going to flip back and forth. And why is it flipping back and forth? That's because in our code, we bind a texture to slot 0, because that's the default active slot. Then we activate slot 1 with this GL active texture. So now we're setting slot 1 to be the currently, you know, what would you call it? Currently active slot. Yeah, I don't know why I didn't just use that word. So then when we bind stuff after that, we will bind them to slot 1 instead of slot 0. So these binds here that we're doing in tick, or whatever you want to call it, in the loop, we're binding that to slot 1. So now that we're sampling from slot 1 instead of slot 0, we're getting this going back and forth between two textures. Cool. So let's make 2 samplers. So I'll call them sampler 0 and sampler 1. All right. So now we have 2 samplers. And what should we do in the code? I guess we'll... Yeah, we have time. Let's just blend between the 2 then. And let's see what happens. So we will do U color. Oh, I should say, by the way, I think something I sort of glanced over very quickly last time is texture returns the color as a vec4. I should say that. So it returns the color of the pixel. If there is an alpha, it will return the alpha. If there is no alpha, I think it returns 0. I actually don't know. Yeah, I'm pretty sure it's 0, but it might even be, you know, undefined perhaps. But it's always returned a vec4 no matter what the texture format is. So that's important to remember. Right, okay. So let's blend between them. So we'll do vec4 color A, and we'll do texture use sampler 0 f text chord, and then we'll do color B texture use sampler 1 f text chord, and then we will set the final color to be mix, which is lerp, linear interpolate. We'll mix color A and color B with the sign of U time times 0.5 plus 0.5. And if you remember this, actually I do it right here. This will change the wave from being from -1 to 1 to instead of being from 0 to 1, 0 to 1, 0 to 1, 0 to 1. Because linear interpolation, again, expects a value from 0 to 1. So let's see what happens now. Okay, so it's white. So that's cool. Oh, yeah, that means we have a compiler. Oops. 23. Okay, so on 23 we had an error. Undefined variable use sampler, right? Because we renamed it to sampler 0. So I'll just remove this line actually. I'll remove that line as well. Yes. Okay. Let's see now. Okay, there we go. So why? Okay, so we're seeing this texture. Why are we seeing this texture? If you look at the code here, can you figure out why are we seeing only this texture and nothing else? Why isn't it blending anything? Well, we're setting a sampler here to be at slot 1, but we did not rename this uSampler here. It's just uSampler and then nothing. While there is no variable called just uSampler anymore, it's uSampler 0 and 1. So since we're not setting any of those two, those have the default value of 0, which means that they both are gonna sample from the same texture. So when we mix one texture with the same texture, nothing's gonna happen. We're just gonna get the same texture back. So I'm gonna get sampler 1 here. So I'm just gonna take one of them. Sampler 1 I think makes sense. So I'll just take one of the uniforms and set that uniform to be 1 instead. And you know, instead of flipping back and forth like this, I'm actually just gonna bind. I'm just gonna bind the textures flat out and don't change them anymore. So I will actually do here. I will load texture 0 and then bind it. And then before I load the second one, I'm gonna do GL active texture, GL texture 1, and then I will load it and bind it. There we go. So now I'm loading texture 0 into slot 0. Then I'm changing the slot 1. Changing the active slot to slot 1. Loading the second texture and binding it. It does get bound in the load texture, so this bind is technically, you know, I don't need to bind here because I already bind in the function, but it looks clearer, I think. So now, okay, let's just map in our head what we've done. Let's just draw it out, actually. I'm just gonna there we go. Gonna make the slots. I don't know why I drew so many. Let's make it absolutely clear what we're doing here. We have two functions, or two uniforms. We have uSampler 0 and uSampler 1. Okay, in code, we're getting sampler 1 and setting it to 1. Okay, so we're doing GL uniform 1 here. What that means is that uSampler 0 will keep its default binding of pointing to slot 0. So slot 0, 1, 2, 3, 4. But we're rebinding sampler 1 to sample from slot 1. Okay. Then we're loading two textures. We're loading texture A and binding it while slot 0 is the active slot. So slot 0 will get texture A inside of it. Then we're loading texture B, or rather, first we're switching the active slot to be slot 1, and then we load texture B. So slot 1 will contain texture B. What this means in our shader, sampler 0 will sample from texture A, while sampler 1 will sample from texture B. So hopefully this is what we see. Or we see nothing and I, panic. Oh my goodness. So now we're mixing the two colors back and forth. Amazing. So we're saving the color from texture A, we're saving the color from texture B, and then we're mixing them. So we're lerping between those two using the sign function. So when the sign function returns 0, we're getting color A, so the color from texture A, and when the sign function returns 1, we're getting the color from texture B. So that's why we're getting the fade in between the two. And since, you know, the sine function is going to be the same for every single pixel. Sine doesn't change ever in the run of a fragment shader, so we get the same fade for every pixel. And let's actually do something fun. Okay, so I just got an idea that I want to try out. What if we don't keep it that way? What if we don't do a uniform blend? So I'm actually gonna send out f position. I'm gonna send the position of the vertex to the fragment shader. So I'm gonna here do f position is equal to a position. All right, I'm gonna do something a little bit naughty, okay? So I'm sending the position of the vertex to the fragment shader. Okay, so I'm gonna take that in here. So I'm just gonna do input vec2 f position. Okay, so now I have the position in the fragment shader, and again that gets interpolated between the vertices. So I'm getting actually the position of the actual pixel. So where the pixel is on screen is what I'm getting in here. And I'm actually gonna put that into uTime. I'm gonna, in the sine function here, I'm gonna add f position x. What's that gonna do? Not the most important part of this video. This is just me being a little bit, you know, having fun, because I love, you know, I love programming and I love mathematics, so I can't help myself. But do a prediction about what you think is gonna happen here. It's okay if you're wrong, but let's see. So it's kind of hard to see, but can you see that the right side kind of fades in a little bit faster than the left side? See that? And we can actually make that way more pronounced if we multiply this. So we'll multiply all of this by 5. Let's see what happens now. You see this strobing pattern? So we're taking the position of the pixel to sample differently from the two textures. And now we don't get a uniform fade in and out. Each pixel is actually doing the lerping differently based on where it is on screen. We're using the screen coordinates of the pixel to drive our mixing function. Probably if I add in the y, I could probably make it go diagonal as well. There we go. So now it's like diagonally in and out, mixing between the two. Fun. Cool. So that's textures, how you do multiple textures, and that's going to be very important coming up. So I think we're done with textures now, and the next video we're going to talk about transformation. Wow, you've seen the Transformers? It's going to be just like that.